Hey everybody, thanks for clicking on this video. Right now we're going to be practicing slope fields. If you want to follow along, the links to the companion worksheet are in the description below. So let's get started. Now slope fields is a method of visualizing an antiderivative. So here we've got a differential equation. Here we've got dy dx equals x. Now, and we have another video where I show you how to algebraically solve for what the original function is. But here we're just visualizing what the function might look like. Now, one method you can use to plot a slope field is to go point by point and say, all right, what is the slope going to be? So at 0, 0, I plug in, and dy dx, that's my slope, is going to be, well, whatever the x value is. So at the origin, the slope is going to be 0. And what we draw is we draw a little line with a slope of 0. And then at 0, 1, my x value is still 0. So that means I still have a slope of 0 here. And then at 2, same thing. I also have a slope of 0 here. And then the same here at 0, negative 1 and 0, negative 2. Now, let's say I go over to 1, comma 0. Now my x value is 1, so that's going to be what my slope is. So I draw upwards like that. And this point, 1, 1, also has a slope of 1. So that's going to run parallel. And so all of these points right here are going to run parallel to that. They're all going to have a slope of 1. And then these over here, this point at 2, 0, that has an x value of 2. So that means it has a slope of 2. Now, one way to tell if you have the difference between a slope of 1 and a slope of 2 is this is supposed to have a slope of 1. So that means I'm supposed to go over 1 and up 1. So this line should be pointing at this point over here. Now this should have a slope of 2, so I should be able to go over 1 and up 2. Well, there is no point over here, but I can go back 1 and down 2. So this should be roughly pointing at that one. And so this should also have a slope of 2. So this should be pointing at that point right there. And this should be pointing at this point right there. So that's what those lines all look like. Now if we go over to here, now we have an x value of negative 1. So now we're going to have a slope that looks like that. And so since the slope is negative 1, we go down 1 and over 1. So that means this little slope line is pointed at the origin. This little slope line is pointed here. And so we bring that one down and that one down. So these all have slopes of negative 1. And these all are going to have slopes of negative 2. So this one is going to go down 2 over 1. So from this, I'm going to be pointing at that line right there. And so since they all have a slope of negative 2, they're all going to be parallel. So here's what the slope field for dy dx equals x looks like. And so here for this one, the slope is entirely dependent on just the x value. Now looking down at number 2, here the x value doesn't enter into it. It's just the y value. So now, anytime the y value is 0, we're going to have a slope of 0. Whereas here, anytime the x value was 0, we have a slope of 0. Now, one way you can do that, and I'll make this more explicit in the next example, is you can say, well, set the slope equal to whatever number you want, in this case 0. And what it gives you is it gives you an equation. And what that equation tells you is that's going to be the form of all the points where the slope is that value, in this case 0. So all along y equals 0, I'm going to have a slope of 0. So all along the x-axis, I have a slope of 0. And so I can also ask, well, what about 1? Well, all along the line y equals 1, I'm going to have a slope of 1. And then for a slope of 2, that's going to follow along the line y equals 2. So all of these points will have a slope of positive 2. So these will all be parallel like this. All right. So now, if I want a slope of -1, those points that have a slope of -1 are going to be along the line y equals -1. That's down here. So I plot that one, and these are all with a slope of -1. And so down below, -2 equals y. So these values, these points, are all going to have a slope of -2. So I'll start here and say if I have a slope of -2, I would go down 2 and over 1, or I would go back up 2 and over 1. So this should be pointing at that spot. So right like that. So that should be right there. And so now we've got our slope field for dy dx equals y. So now looking at the next one, now we've got both x and y here in this slope field. Now one thing I'm going to do is I'm going to say, well, what happens if the slope equals 0? Well, that means I'm going to substitute 0 in for dy dx. So 0 equals x plus y. And so what I get is, if we solve for y, we get the equation y equals -x. So y equals -x is all the points where the slope is 0. So here's y equals -x down this way. And so all along here, I can just draw these with a slope of 0. So 0 here and 0 here. So now let's try a slope of 1. So I set 1 equal to x plus y, and if I solve for y, I get y equal to -x plus 1. So now this line right here is going to have a slope of +1. All right. Now what I'll do is I'll just draw this little dotted line right here, connecting all of these to say right here the slope equals 0, and right along here the slope equals 1. Now what about if we said the slope equals -1? We'll plug -1 into our differential equation, x plus y, and so y equals -x minus 1. And so there is this line right here. And so all along here we should have slopes that are -1. So -1, -1, -1, -1. Now hopefully we start to see a pattern here. If I go out one more and say -x plus 2, that means we're going to have a slope of +2. And so I can follow that pattern and say that these all have a slope of 2, this will have a slope of 3, and this has a slope of 4. Likewise, I can go backwards and say, well, if these points have a slope of -1, then these points down here should have a slope of -2. -2, -2, -2. So then I have -3, -3, and -4. Now when you draw slope fields, it's very hard for any value past -2 or +2 to be able to eyeball it and say whether that's, oh, well, that's 2.5, or no, that's 3.5. You really can't tell just from the eyeball method. All right. So let's try the next one. dy dx equals x over y. So let's see. If we set my slope equal to 0, that means 0 equals x over y. And so what I get is I get x equals 0. So that is all along here. So all along this line, I'm going to have a slope of 0. All right. Now what about if I have a slope of 1? That means 1 equals x over y, and if I were to multiply the y out, I would get y equals x. So that means along here, I should have a slope that equals 1. So right here I have a slope of 1, right here I have a slope of 1, right here I have a slope of 1, and right here I have a slope of 1. Now notice I don't include the origin. And if you think about it, at the origin both x and y are 0. Well, that means the slope should be 0 over 0. That's undefined. And so because it's undefined, we sort of keep a hands-off approach and we don't draw the slope at that point. So let's try -1. So -1 equals x over y. So that means -y equals x, or we're more familiar with y equals -x. So at this point, all of these points have a slope of -1. Again, I don't include the origin. So what about this point right here? Here I have an x value of 1, and I have a y value of 2. So that means I should have a slope of 1/2. So that should be like that. And this means right here that I should have a slope of -1/2, like that. Here I've got an x value of 2 and a y value of 1, so I should have a slope of +2. Now here, my y value is opposite, so that means I have a slope of -2. And really all I can do is I can use these corresponding points to fill in these other spots on the slope field. So if this point right here, 2, 1, has a slope of 2, then over here, -2, 1 should have a slope of -2. And -2, -1 has a slope of +2. And so if this point at 1, 2 has a slope of 1/2, then -1, 2 has a slope of -1/2. -1, -2 is going to have a slope of +1/2. And so that is our slope field for x over y. Now for number 5, very similar, except we have the reciprocal. We have y over x. So now, if I set my slope equal to 0, that means 0 equals y over x. So if I multiply the x over, I get 0 equal to y. So that means along the x-axis, I get slopes of 0. But here again, I'm not filling in the origin, because if I were to fill in the origin, I would have 0 over 0. Can't have that. All right. So let's try m equals 1. So I want to find all the points where the slope is 1. So I have y over x. So I get y equals x. So all along here, I'm going to have a slope that's equal to 1. Again, not filling in the origin. And so here, if I want the slope, all the points where the slope is -1, I put -1 in for dy dx, so y over x, and so I get y equal to -x. And so up to right now, this slope field is starting to look a little bit similar to the last one. So m equals -1. All right. So now, at this point, I can just use these 2 points and use my symmetry to figure out the other slopes. So here, my x value is 2 and my y value is 1. So that means that's a slope of 1/2. Which means this point down here should have a slope of -1/2. This point, both x and y are negative, so that means we have a slope of +1/2. And this x is negative, but y is positive, so that means we have a slope of -1/2. Up here, I've got 1, 2. So my slope should be positive 2 over 1. Down here, my y value is opposite, so I have slope of negative 2. Here they're both opposite, they're both negative, so it's positive 2. And then finally this one is x value is 2, but the y value is positive, so we have a negative. The interesting thing about this slope field is all the slope field lines should point back to the origin. It's kind of like an explosion. Everything is just flowing out from the origin. All right. And then this last one, we have x minus y. So again, let's find all the points where the slope is 0. And that's going to be y equals x. So I draw this. And so for here, the slope is going to equal 0. So I've got my points here, here, and here at the origin it's okay. It doesn't make it undefined if I subtract 0 minus 0. That's going to work. So let's try 1. 1 equals x minus y. Now what I'm going to have to do is I'm going to have to add y, so it's y plus 1 equals x. And then I'm going to have to subtract 1. So y equals x minus 1. And so what we get is we get this line right here, m equals 1. So all of these lines are going to have a slope of 1. Now, if I plug in negative 1, I get x minus y equal to negative 1. If I add the y over, I have y minus 1 equals x, and then I add 1, so y equals x plus 1. So the line y equals x plus 1, that's all the points where the slope is equal to negative 1. So here I draw that point down, 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 and down like that. Now, at this point I can start to see a pattern here. If I just move it to x minus 2, that means I'm going to have slope of negative 2. Negative 2, negative 2, negative 2, like that. This is going to be negative 3. Whoops, I did that backwards, didn't I? Those numbers should have been up there. I should have a positive slope here. Positive 2 and positive 2. And this should be positive 3, and this should be positive 4. So m equals 2, m equals 3, m equals 4. So over here, my mistake, over here along this line we should have a slope of negative 2 here, negative 2, and negative 2. And then we have negative 3, and then negative 4. Thanks everyone so much for watching this video. If you liked it, give it a thumbs up. For more videos like this, click the subscribe button. If you're a teacher and you found this helpful, share it with your classmates, with your students or with your colleagues. If you're a student and this helps, share it with your classmates. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching. And remember, the best way to understand something is to do it.